Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is the first major examination of Math 111, Term 241. Let us have a look to the exam and solve it together. Use the graph of f to find the following limits. Explain your answer. Limit f of x when x approaches 0. Well, to find the limit of the function, this is the graph of the function on f when x approaches 0. So this is the x-axis. I need x to approach 0. So let me approach 0 from the right. The function is going up to the number 2. If I approach 0 from the left, also the function is going up to number 2. So the limit is 2. And to explain my answer here, I can write that the limit when x approaches 0 from the right of f of x is equal to the limit when x approaches 0 from the left of f of x is equals to 2. List all the points where the function is not differentiable. The function, okay, let me answer part C and then I'll go back to part B. The function is not differentiable if it is not continuous, or there is a corner, or there is a vertical tangent. Well, at -3, it is not continuous. At 2, at 0, it is not continuous. There is a hole. At 1, there is a corner. At 3, it is not continuous, so it's not differentiable at these points when x is at x equals these points, or these values of x. Limit f of x when x approaches -3. Okay, x approaches -3. So this is -3. Here x is -3. Let me approach -3 from the right. The function, the graph is going up to 0. So limit f of x when x approaches -3 from the right is 0. While if I approach -3 from the left, the graph is going down to 2. So limit f of x when x approaches -3 from the left is 2. And this means the two limits are not equal. So let me write here not equal. So if the limit from the right is not equal to the limit from the left, then the limit when x approaches -3 does not exist. Find the inverse of this function. Well, the first step is to call it y instead of f of x. And then we solve this equation for x. To solve it for x, I have to get rid of len. So I raise both sides to the base e. E cancels len. So I'll have e to the power y equals e to the power 2x minus 10. I need to solve it for x. So I'll take 10 to the other side. So e to the power 2x would be equal to e to the power y plus 10. Now to solve it for x, I need to apply len to both sides. Now applying len to the right-hand side, you should write it like this. Len cannot be distributed if there is a positive or negative sign. If you remember the properties of len or log, it works with products and division. We know that len u times v equals len u plus len v, and len u over v equals len u minus len v. But we don't have a formula for len u plus v. There is no formula for that. So you keep it like this. Expanding this, writing it y plus len 10 is not correct at all. It's a big mistake. So len cancels e and we'll have 2x equals len e to the power y plus 10. Finally, to solve it for x, just divide both sides by 2. So we solved the equation for x. Now we interchange x and y. So this is in fact the inverse function, and let us write it as f inverse of x. So f inverse of x would be len ex e to the power x plus 10 over 2. And here you can check that your answer is correct. Choose a number, here, choose a number for x, and find y, and put the value of y here, and make sure that f inverse will give you the same. I mean, if x goes to y, then f inverse takes y to x. But you need a nice number here. For example, if I take x equals 5, so I'll have e to the power 10 minus 10. And taking len, I'll have 9.999. So in fact, 5, f of 5 is 10. This is just for checking. So f inverse of 10 supposed to be 5. So if I replace x by 10 here, so if I find len e to the power 10 plus 10 over 2, the calculator says 5.0002. So I'm sure that my answer is correct by this checking. This is just a check, okay? So you don't have to write it. You may write it somewhere. This is for checking, just checking that your answer is correct. Okay. Use transformations to graph the function. He needs 3 graphs. Well, first we start by the graph of the original function, square root of x. We know that the graph of square root of x is like this. Then, according to the order of transformations, we know that the order of transformations follows this rule H SRV, Saudi Real V, or HSRV, where H is the horizontal shifting. We don't have a horizontal shifting here. So S stretching, we don't have stretching. Reflection. Now we need to draw the reflection. So the reflection means we draw this function. And here we multiplied y by negative, so it's a reflection about the x-axis. So the graph would be like this. And now we do the vertical shifting. So this would be the graph of f of x. We take this graph 3 units down, so the graph would be like this. So this is the point -3, and that's the graph. Use the intermediate value theorem to show that there is at least one solution of the equation in the interval 0 to 2. We start by taking 1 to the other side and call the left-hand side f of x. And now we find f of 0. Well, f of 0 is just -1 and it's negative. And then we find f of 2. F of 2 would be 8 minus 4. That's 4 minus 1, that's 3. And it is positive. So by intermediate value theorem, there is a 0 or a solution between 0 and 2. Okay, you can say 0 of the function or solution of the equation. Both are okay. Evaluate the following limits. This is by squeeze theorem. The limit would be 0 by squeeze theorem because sine 6x, 6 over x, is between -1 and 1. And if we multiply by x squared, then we will have this inequality. And we can simply find the limit of negative x squared when x approaches 0, and limit x squared when x approaches 0. And if you replace x by 0, the answer is 0. So by squeeze theorem, limit what is in the middle, which is x squared times sine 6 over x when x approaches 0 is 0. To find this limit, if I replace x by -2, I'll find the answer is 0 over 0. So I try by factoring. It is x minus 2 times x plus 2. That's the factored form of x squared minus 4. And here, 3x and x, I must have plus 2 because x goes to -2 and 0 over 0, so I must have x plus 2 here, so minus 5 here. Now minus 5x plus 6x will give you x, and minus 5 times 2 will give you -10, so that's the correct factorization. And now there is a cancellation, and the limit would be limit of x minus 2 over 3x minus 5 when x approaches -2. -2 minus -2 is -4, and 3 times -2 is -6 minus 5, that's -11. So the answer is 4 over 11. Find the horizontal asymptotes of f of x. To find the horizontal asymptotes, we need to find the limits of the function when x approaches infinity and -infinity. How to find the limit when x approaches infinity? I take the highest power in the numerator, the term with the highest power, over the term with the highest power in the denominator. What do we know about square root of x squared? We should know that it is absolute value of x. But when x approaches infinity, then x is positive number and absolute value of x would be equal to x. X cancels with x and the limit would be 5. Now the limit when x approaches -infinity would be the same up to 5x over absolute value of x, but here x goes to a -infinity, so absolute value of x would be equal to -x. X cancels with x and the limit is -5. So the equations of the horizontal asymptotes, y equals to 5 and y equals to -5. Study the continuity of the function at x equals to 3. Well, I need to check that f is defined at 3. Yes, it's equal to 4. I need to find the limit when x approaches 3. The function changes, the definition changes around 3. So I'll find the limit when x approaches 3 from the right. From the right, if x is greater than 3, then this is the definition of the function. And replacing x by 3, I'll have 9 minus 6, so I'll have 0 over 0. So how to evaluate this limit? I need to factor. So I have x minus 3 times x plus 1. X squared minus 2x minus 3. Okay, correct. Now you can cancel x minus 3 with x minus 3. And you can replace x by 3. 3 plus 1 is 4. And this is equals to f of 3. So the function is continuous from the right. You can say that f is continuous from the right, if you like. It's not necessarily. Now the limit when x approaches 3 from the left, I'll have this root, because if x is less than 3, that's the definition. 16 minus sine x minus 3. Well, if I replace x by 3, sine 0 is 0. So the answer is square root of 16, which is 4. And this is again f of 3. So in fact, the function is continuous from the left. So you can say that the function is continuous at 3. And you can write that the limit when x approaches 3 of f of x is equal to 4 is equal to f of 3. So f is continuous at 3. Given f of x equals x squared plus 15, find the derivative of f prime of 5. Well, f prime of 5 has two definitions. Either it is limit when x approaches 5 of f of x minus f of 5 over x minus 5. And for these definitions, please go back to the material, to the sections. This is in section 2.7, I believe. So if x approaches 5, I'll have, what is f of x? It's x squared plus 15. And what is f of 5? F of 5 is 25 plus 15, that's 40, over x minus 5. So 15 minus 40 is 25. And if I replace x by 5 now, I'll have 0 over 0. So I need to factor. So x minus 5 times x plus 5 over x minus 5. Cancel x minus 5 with x minus 5 and replace x by 5, so the answer is 10. So f prime at 5 is 10. Or there is another formula to find f prime of 5. It is the limit when h approaches 0, f of 5 plus h minus f of 5 over h. And f of 5 plus h would be 5 plus h to the power 2 plus 15, where I replaced x by 5 plus h, minus f of 5, which is 40 over h. And let us simplify this limit. Let us expand the square. So I'll have 25 plus 2 times 5 times h, that's 10h, plus h squared, and 15 minus 40, that's minus 25 over h. Cancel 25 with 25 and take h as a common factor from the numerator. Cancel h with h, then replace h by 0. So the answer is 10. So f prime of 5 is 10. This was the last question in the major. Hopefully you enjoyed this video and learned. Okay. Thank you very much and see you in another video.